Hey everyone, Mrs. Garcia here. Today we're going to be talking about notes over solving equations. But before we begin, I'll kindly ask that you have your name in the upper right-hand corner in pen. I will also remind you that in order to receive credit for these notes, that your notes must look exactly like mine, other than the fact that mine says name and yours will have your name. So anything I have written, you have to have it written too. Now I'm aware you might not have access to all the colors, and that's okay, but if I write it, you have to write it as well. So let's go ahead and get started with some vocabulary. So remember that the number in front of the letter, when you have a term like this, 2x, is called the coefficient. The letter in the back is called the variable, and a common variable that we work with is x, but you might see x, y, z, you might see q, r, s, t. Okay, you might also see more than one variable, but I just wanted to remind you of what those terms are because we're going to be using them today. So in my class, if you're asked to solve something like this linear equation here, I've written it twice on number 1 because there's 2 acceptable ways to work through this problem in my class, and I'll show you both. So probably most of you are familiar with the way where, and I do like this organization, where you draw the line down the middle, and of course we're trying to isolate the variable. So that means get the x by itself. So we want to get rid of the plus 9 and this 5 here. So how do we go about that? Well, first, you don't have to write this, but I do want to remind you that we have these things called inverse operations. Addition and subtraction are inverses, and multiplication and division. So if I've got plus and I want to get rid of it, I'm going to subtract. Likewise, if I've got minus and I want to get rid of it, I'm going to add. And then vice versa here. If I want times, if I've got times and I want to get rid of it, I'll divide, and then vice versa. So I just want to remind you of that really quick. So in this case, I have a positive 9 that I want to get rid of to isolate this x. So I will subtract 9, and what I do to one side, I must do to the other. I have to balance that equation, right? So then here, you will learn as the year goes on, I hate the word cancel. Please do your best to not use the word cancel, and so will I. This does not cancel, it adds to 0. So positive 9 and negative 9 add to 0. We don't write it. It'd be silly to write 5x plus 0. It's not worth it. So 5x equals, and then this becomes negative 5. And then here this is 5 times x, so remember that your inverse operation for multiplication is division. So to get rid of the 5 times x, we will divide both sides by 5. And then again, I don't like the word cancel because cancel really to me means 0, but this doesn't turn to 0, it turns to what? What's 5 divided by 5? 1. Now I know we don't write the implied 1 because it's implied, but like I said, it's implied. So 5 divided by 5 is 1, we don't write it, it's implied. Here, in this case, we do need to write it, this is negative 1. Okay, so that's our final answer. So the other way that's acceptable in my class, and I'll probably gear more towards this one, especially because it takes up less room, is this. So again, you're trying to isolate the variable. So that means I want to get rid of the plus 9. I'm still going to draw my line down to make it very organized. And that I know needs to jump across the equal sign. So anytime anything jumps across the equal sign, what happens? Well, it changes signs. So the 5x will drag down, and of course the 4 still stays, it drags down, but that plus 9 on this next line becomes minus 9. Please don't write it on that line because that would be mathematically incorrect. Okay, so write it on the next line down. So, and I do need to see it for now. Once I get to know you more, you might be able to skip more steps, but until I get to know you, please just write all the steps. So here that combines to negative 5. So again, from here it's the same, divide both sides by 5, and we get, this turns to 1x, which we don't write, it's implied. X equals negative 1. Okay, another thing we're going to be doing a lot of in my class, and that's a good sign that we got negative 1 no matter which way we did it, right, is checking our solution. We're going to do this especially when we get into the more difficult problems this year, so I definitely want to make sure you know how to do it with the easier problems. So how do we check our solution? Well, we take the original given problem, and you remember this is the biggest thing. I need you to remember this, like ingrain this in your brain right now. You are never, ever, ever allowed to move anything to the other side when you're checking. When you're checking, you can't do like what we did here, and you can't minus 9 from both sides. Just remember that, please. Please, 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 just remember that. So here what we're going to do to check is we're going to plug in our answer of negative 1 anywhere we see x. So we plug in negative 1, and now here we can't write equals. We really have to write equals with a question mark because we're not sure. Is that true? Did we find the correct answer? So I'll remind you again, and I'll probably remind you a million more times so you don't make this mistake. You're not allowed to move anything. So I cannot minus 9 from both sides. I just need to simply figure out what this value is. So this is 5 times -1, which is -5, plus 9 equals question mark 4. I'm not sure, does it? Well, yes, it does. -5 plus 9 is 4. So 4 equals 4 is a true statement. We're good to go. We checked our solution. Okay, let's move on to the next problem. So number 2. Okay, so here we've got this problem, and hopefully you're looking at this and you've seen this before, and you hopefully remember that you need to distribute first. Before we can start collecting like terms or moving things to other sides, you see these parentheses here, and that really tells you right away I've got to distribute first. So you're going to distribute first, and you get 3x minus 6 plus 5 equals 8 minus 4x. So then you can combine your like terms if you have any, and we do in this case on the left. So 3x, I'm going to draw my line, make it organized. 3x minus 1 equals 8 minus 4x. And then I start to move sides. So here, remember, I've got a variable on each side of the equal sign, and I want the variable all by itself on only one side of the equal sign. So what I do is I always look at the coefficients on the variable, and I see which one's larger, and that's the side I move my variables to. That's how I decide. So 3 is certainly bigger than -4, so I'm moving variables to this side. That means I'm going to pick this up, and I'm going to move it over here. So if variables are going to be on the left, then constants, numbers without variables, are going to go to the right. Okay, so the 3x stays. The -4x moves over here and becomes positive 4x because it jumped across, so it's got to change. The 8, the constant of 8 stays. The -1 jumps across, so it becomes positive 1. Then I can combine. 7x equals 9. Divide both sides by 7, and I get 1x equals 9/7. Another note I want to make for you really quick. In my class, you must stack fractions. This is no longer algebra 1, it's algebra 2. You're not allowed, don't slant. We are not going to be working with baby numbers this year, okay? So if you write this, x equals 9/7, and you get used to that, it's not going to work when we get to the larger numbers because it won't be mathematically correct. So never do that, always do this, okay? So now let's check our solution for this one. So what have I done? Well, I've rewritten the original problem, and now remember, anywhere you see x, you're going to plug in that solution of 9/7. This is why I'm telling you at the beginning of the year that we've got to be comfortable with our fractions, because look at how ugly this is about to be. But you can handle it, right? Because we're going to get very comfortable with fractions. We've got to be. We're going to be working with them all year long. So here I've plugged in 9/7, my answer to my problem, anywhere I see x, and remember I need that question mark now. I'm not sure, is this a true statement? Did I make a mistake here or did I not? So the first thing I want to remind you of is when I'm checking, I cannot move anything across the equal sign. I cannot. Okay, I need to just follow PEMDAS and figure out what this number is on the left and figure out what this number is on the right. PEMDAS says I've got to do what's in the parentheses first, so I will follow that. So this 9/7 minus 2 would really be 14/7, right? Because I've got to get that common denominator. So 9/7 minus 14/7 plus 5. So then now I can legally combine these. This will be -5/7 plus 5. Now I can finally multiply because I've taken care of the parentheses. I have no exponent other than 1. So now I can multiply 3 times -5/7. So remember that's -15/7. If I'm going too fast with the fractions, you need to go back and watch your fraction video. Okay, equals, and then question mark, question mark, question mark. All right, and then here, last thing, -15/7 plus this will be 35/7 to get that common denominator. So this will be 20/7. So equals question mark equals question mark. So we want to see, does the right equal 20/7? So here again, following PEMDAS, I want to get that common denominator so I can combine those. So 14/7 minus 9/7. So this is going to be 5/7. So now I can multiply, that's going to be 4/1 really. So 20/7, what do you know? 20 over 7. So we're good. We just checked our answer. Will I require you to do that every time? No, but it's a great tool to have. I will require it sometimes, but it's a great tool to have, especially for a test or something like that. Okay, so number 3. So here we are. Remember, again, PEMDAS. This is a big thing. A lot of students see this problem and they want to do, oh, 7 minus 2, it's 5. No, you cannot add or subtract before you distribute first. So remember, distribute first. Follow the multiply before you add or subtract. So here you get negative x minus 5 equals, drag the 7 down, this becomes negative 6x plus 2. On the right here, I can combine the 7 and the 2 to give me 9. So I've got negative x minus 5 equals, let's make that 9 minus 6x because I combined the 7 and the 2. Okay, now I look at my coefficients on my variables, negative 1 and negative 6. Negative 1 is larger than negative 6. Therefore, I will move my variables to the left. Therefore, my constants, my numbers with no variables, will move to the right. So this negative x remains. The negative 6x becomes positive 6x. The 9 remains. The negative 5 becomes positive 5. And I get 5x when I combine equals 14. Divide by 5, divide by 5. I get x equals 14/5. And make sure you box that answer up, because it won't simplify, you're done. And I won't make you check that one for sake of time. Okay, on this problem here, I don't have any distributing I need to worry about. Again, I'm just trying to isolate that x. So I'm going to minus 5 from both sides, or in other words, just for sake of space, I'm going to move this over. So the 1/4 x, make sure that x looks like it's in the numerator. If it looks like it's in the denominator, that's something totally different. We'll talk about it later in the year. So 1/4 x equals negative 2, that becomes minus 5. And then 1/4 x equals negative 7. And here we need this side note, multiply by the reciprocal. So you've got this fraction, and the easiest way, in my opinion, to get rid of it is to multiply by the reciprocal, because remember, we want x isolated. So the reciprocal of 1/4 is 4 over 1. So what I do to one side, I must do to the other. So remember, this 4 and this 4 simplify to 1 and 1. So I've got 1 times 1 and 1 times 1. So that's just 1x, like we want, a single x equals, and this becomes negative 28. So x equals negative 28. Sorry, that line was kind of looking like a negative sign. I didn't want to confuse anybody. Okay, next problem, almost done, 2 more. So here on this one, again, we don't have any distribution to take care of. I look at my x's. I can't combine like terms or anything, so I look at my x's. My coefficient on x is 2 here, 3/4 here. 2 is bigger than 3/4. So that means I'm going to make this guy jump across. That means my constants are going to come over here. So I will have 2x on the left. This 3/4 will become negative 3/4 x. Again, remember, make sure that x looks like it's in the numerator. Equals, and then the 9 stays, positive 9. That negative 1 becomes positive 1. So here I'm going to have to get my common denominator. So that's going to be 8x over 4. Isn't that right? 8 over 4 is 2. Yep. Minus 3/4 x equals 10. Okay, and then 8 over 4 minus 3 over 4 is 5 over 4x, and you can, kind of like I did there, keep the x in the numerator, or you can off to the side as long as it looks like it's in the numerator, that's fine. So 5/4 x equals 10, and then you have another situation like above, where to get that x isolated, you're going to multiply by that reciprocal, so 4/5. So of course here the 4 and the 4 simplify, the 5 and the 5 simplify, it's all 1 all around, so that just becomes 1x equals, this is like 10 over 1, so the 10 becomes 2 while the 5 becomes 1. So this is just 8. So x equals 8. All right, thanks for bearing with me. Last problem here. All right, last problem. So in this problem, unlike the previous two where I only had one fraction, I've got 4 fractions. So I want to clear the fractions. Now, will this method work on these two problems? Sure. I just thought because it was one fraction, it wasn't horrible, so I would just deal with it. But in this case with 4 fractions, I don't just want to deal with it. Okay, so I'm going to clear the fractions, which means multiply every single term by the LCD. Okay, so what's the LCD? Look at your denominators. 4, 12, 3, 6. My LCD is 12 because 12 would evenly, all of these numbers would evenly go into 12. So that means I'm going to multiply every single term by 12. This term gets multiplied by 12. This term gets multiplied by 12. Remember, that plus doesn't belong to it. It's just a plus sign in between. This gets multiplied by 12. And again, that minus sign doesn't belong to this. So that's why I'm not putting it in the parentheses. It's a minus sign. And then multiplied by 12. So every single term got multiplied by 12, or 12 over 1 if you want to think of it that way. Okay, so then you can simplify and you'll see how beautiful this becomes. So the 12 over 4 simplifies to 3 over 1. The 12 over 12 simplifies to 1 over 1. The 12 over 3 simplifies to 4 over 1. And the 12 over 6 simplifies to 2 over 1. If you've done everything properly, all the denominators should be 1. Why? Because I'm clearing the fraction. I don't want fractions anymore. So here I have 3 times y, which is 3y. Drag the plus sign down. 1 times 1, which is 1, equals, and then 4 times y, which is 4y. And then don't forget to drag the minus sign down. And then 2 times 1, which is 2. How beautiful. And then I look at my coefficients, 3 and 4. Yay, finally my coefficient is larger on the right. So I'll get my variable on the right, which means my constants need to go on the left. Okay, so the 1 will stay, the negative 2 will become positive 2, the 4y will stay, and the 3y will become negative 3y. So then when I combine, I get 3 equals y, and that's okay if you leave it like that for me.